record this. And if you have it in, let me know, and let me know, and I'll definitely let them in. It's not like a secret meeting. Well, that would be cool though. No, you're not allowed in. Okay, so. Okay, so the topic for today is scale factor, and what we're going to look at is how do we use scale factors, and maybe where do we see them? Where do they actually occur at? So say that you're looking at this beautiful picture of my house, okay? Okay. So I've got numbers spray painted on my windows and stuff, and let's say you were saying, well, I said, well, this is my house. This is my house here, and of course there are people that are very literal in life, and they would say that's a small house to live in, and they would actually think I'm saying that this actually physically is my house on the page here. Now, of course, I could easily just sort of show them that, look, I can make my house really big, or I can make it really tiny. And I can do lots of weird things. So I can scale it just by touching the screen and move it to different sizes here. But clearly this is just a picture representation of what my house is. And I'm just going to make up a number here. I have no idea if this is true or not. But let's say my real house is I don't know, let me guess here. Let's say it's 35 feet. Well, my daughter was using this for drawing, so she's choosing some pretty cool colors here. So let's say that it's 35 feet tall, my actual house, my house here. And let me get rid of that. Let's try that again. So 35 feet tall. Okay. And you're kind of like, well, you know what? Obviously, that picture is not 35 feet tall. I can tell that pretty quick. But if I took my ruler and I was measuring it, and I kind of used a ruler to figure out how tall this thing was. And let's say you on the ruler you figured out that this distance in the picture was 1.5 inches. And we could do a different question in metric if we wanted to, but let's just kind of go with those numbers. I chose these units because we've done some questions on unit conversions and stuff. So so let's say you were saying, well, what is the actual scale factor here for this house and the real house itself here? Because obviously this is quite small here. Because what you're trying to say is that this distance here is actually 35 feet. But when you use your ruler, it measures 1.5 inches on the picture. So the picture is a representation of the real object here. So first of all, I think we want to work in the same units. So we want to choose the same units here. So I could convert inches to feet or feet to inches, and I might work in inches here. So let's say the picture is 1.5 inches. So it's 1.5 inches. And then now what I have to do is take the feet and turn those feet into inches here. And so we have to know a conversion factor for that, which is what we've been doing last week. And if you were in class yesterday, we did some questions like this too. So if we convert 35 feet into inches, then we would want the feet in the denominator. So we want to get rid of the units feet, and we want inches in the top. And then we have to know how these units are related to each other. And it turns out that 1 foot is equal to 12 inches. And just before I go any further with this, there was a student who had asked me a question about the test, or when we do the test, what would they would they be expected to know that specific information? And so I would say in your daily life, it is actually useful for you to know that. I think there's a lot of times in your life, maybe not at your age now, but when you get older, knowing how many inches are in a foot is actually a really important thing to know. but I will be giving you a sheet that shows you all the unit conversions, so you don't have to memorize those for the test, or try to look them up whenever you're doing the test. So, but I would say there's some units that are really useful. Like for example, knowing that a kilometer is 1,000 meters. That's a pretty useful thing to know. But anyways, it's just to clarify that on the test, I will give you a sheet that shows you all of the unit conversions for that. Okay. Okay, so if we times these numbers together, I'll use a nice rainbow kind of color here. 35 multiplied by 12 is going to give me 420 420 inches. Sorry. Okay, so clearly we can see that this diagram that you have 1.5 inches on here, and that's the same as 420 inches. And I'm going to just clarify what I mean by that, because those are not the same numbers. But what we're saying is that 45 inches in the picture is the same as 420 inches in the real world. Okay. So that's kind of the connection here in the diagram. So 1.5 inches is the same as 420 inches here. But sometimes people will say, well, the scale factor is so many inches to a foot here. So another way of representing this is that you could say 1.5 inches. So that's in the picture, is equal to 35 feet in the real world. So basically the real world distance is that, and the picture distance, or sort of the imagined or scaled picture, is 1.5 inches. And if you were to look on a diagram, they might give you a scale factor down here. They might say, you know, here's the scale, and they say like 0 to 1. And they tell you what that refers to. So that's where we use this information here to get the actual scale factor of the picture here. The work I did here, I'm just gonna choose a different color here. The work we just did here, this part right here, is just showing the connection between the actual picture and the real dimensions in the real world in the same units. So what we could look at is, let's take 35 feet, and let's divide it by 1.5 inches. So if I do that, take 35, divide by 1.5, and that gives me 23.3. It's repeating. If you use your calculator, you get 23.3333333. And now I guess the question is, what is that telling us? Like, what does that 23.3 mean in the first place? Well, what's really important here is, if you notice how the units are written, we have feet over inches. So we just continue that term. We would say that we have 35 feet, sorry, 23.3 feet per inch. And what that means is that every inch on your diagram would be the same as 23.3 feet in the real world. So let's do a question where we tell you the scale factor and see if you can kind of determine how big something is here. Okay. So let's say you're looking at a really tall building downtown, and someone draws a picture of it. Draw me another building here. You can see I'm a really good artist. And let's say the first building, building A, building B, because it's a city full of math people that name their buildings letters. And let's say that on your picture here, you measure this to be, let's use some metric stuff here. Let's use, what does it look like? 1, 2, 3, 4. Let's say it was 5 centimeters. Okay. So it's 5 centimeters tall, and building B is maybe 2.5 centimeters. Okay. And let's say at the bottom here, you're told down here, and they kind of have like 1, 2, 3, 4. So 0, 1, 2, 3, 4. And let's say these are centimeters. This distance here is 1 centimeter on your ruler. But they tell you that this is, sorry, let me rephrase that again. I got a room here. So they tell you that like they have the scale of measuring in centimeters on the bottom, but the top numbers are all in meters. So for example, this 1 centimeter right here is 300 meters. If it's 2 centimeters, it's 600 meters. If it's 3 centimeters, it's 900 meters. And if it's 4 centimeters, it's 1200 meters. So I'd like you to see if you could take building A, and it's currently 5 centimeters tall. I'd like you to think about what conversion factor using the scale here you would use to determine the actual height of the building. So in the picture, it's 5 centimeters tall, but what's the real height of the building here? So think about all that stuff we did with unit conversions, what might actually go in there, like what you'd want to cancel. And what we're going to try to find out is how tall is the building in meters actually? How many meters tall is the building? So I want to give you like maybe a minute just to think about that, or maybe 30 seconds to think about that, and then you can write down your answer, and I'll set up question B too. Yes, thank you, Natalie. So in terms of the scale factor, you'll notice that you kind of have to read the bar at the graph to sort of see what the scale factor is. And there's many ways you could determine that, but I think the way Natalie's done is probably the best way, is to find out what 1 centimeter is in the picture. And so in this question, you can see 1 centimeter lines up nicely with 300 meters. So really, you can write that as a ratio. Some people might write this, like 1 centimeter equals 300 meters. But of course, as a math person, that just sounds weird to say that. Like you're saying, well, 1 centimeter is 300 meters. It's not really, that's not really true. But on the scale factor, you could think of it as a ratio, I guess. Like it's really 1 centimeter to 300 meters. They're equivalent to each other. So in the fake world, 1 centimeter is what you're seeing, but in the real world, 300 meters is what you actually would see. So just like unit conversions, we know that we got to get rid of the centimeters. So they're going to have to go on the bottom of the fraction. Meters are going to have to go on the top. And what you wouldn't want to make a mistake here is to do something like this. You wouldn't want to say, oh, well, 1 meter is 100 centimeters. Because that's actually is the relationship between meters and centimeters. But this is what we call scale factor. So the conversion factor you use is related to the scale factor, not the relationship between the units themselves. So we want to make this what it means in the diagram. So every 1 meter, sorry, that's not true. For every 1 centimeter in the picture, that actually equals 300 meters. And you can sort of see why I was saying this might sound weird to somebody if you just said that to them. Oh yeah, 1 centimeter equals 300 meters. They might think you're like on crack or something like that. But anyway, so 1 centimeter is not equal to 300 meters. But in this diagram, 1 centimeter is equivalent to 300 meters. So then we would just time these numbers together, and this would be a rather tall building. 1,500 meters tall, so 1.5 kilometers. I don't know if that's actually realistic in Victoria. I don't. Actually, I know that's not realistic. But anyway, but the idea is how do you use these numbers? I'm kind of coming up with them on the top of my head. So why don't you guys answer the next question? And I think that should be pretty quick for you if you kind of know the scale factor here. 750, I believe you are correct, yes. So same scale factor. So once again, get rid of centimeters, go to meters. And once again, the scale factor says that for every 1 centimeter, you get 300 meters. And so we times that together. So we're gonna get 750. The other way, of course, looking at it is you're basically halving the original distance. You're dividing that by 2. So you could have just divided that by 2 also. But I kind of wanted to show the scale factor here, how we use that. Now, just a bit of what can be tricky sometimes is let's say I didn't give you a scale factor that was as nice, and I said here's 0, here's 1200 meters. So I'm kind of using the same scale factor here. But maybe on the bottom, what I wrote to you was like you measure this. Sorry, you use a ruler and you measure this distance to be 4 centimeters. So instead of me giving you these numbers, or maybe you're looking at a map and not giving you specifically those numbers, and they say to you, this distance here represents 1,200 meters, just like it did in the other diagram, but they don't give you the 1 centimeter increments. They just say that this entire distance is 4 centimeters. So the question is, how do you get the scale factor from that kind of information? Because it's obviously it's the same scale factor, but how do you actually get the same? How do you get that number? How do you get this number here to work? And so what you do is you basically you take the number. You say, well, 1,200 meters is the same as 4 centimeters. And of course, those two dots, that just means like a fraction. So it means 1,200 meters over 4 centimeters. And if you use your calculator and divide that, you're going to get 1,200 divided by 4, which is 300 meters per centimeter. And so you actually get the same thing here. And in fact, even if you didn't want to reduce the fraction, if you just wrote this in 1,200 meters centimeters, you actually get the same answer if you plug it in. You don't necessarily have to reduce it, but it might be nice to reduce it because you get a better perspective for yourself. Okay, what I 1 centimeter looks like, that's supposed to be 300 meters. So that's a good question when you're going from like a diagram to something in the real. How tall is this real structure really? But you can also go the other way is you could look at something kind of try to draw a picture of something. You kind of keep scale in your picture. And there's lots of neat tricks artists use actually that some people like myself are not artists and have to do that. So sorry. Okay, so we were here. And what I was saying was sorry, what I was going to say was the ratio. You don't necessarily have to reduce this ratio. You could just multiply through by 1,200 over 4, and you actually would get the same answers. And then what I was going to look at was if you were maybe taking something in the real world and trying to draw it, like make your own map of something, or maybe you're trying to do a picture of something. You kind of want all your objects to be the same scale. So for example, if you had like this mountain here, and then there was another mountain over here, and let's say you drew this one, and it was 7 centimeters tall. And so that mountain here is 7 centimeters tall when you draw it. And in the real world, that mountain is actually, let's say it's 420 meters tall. So in the real world, like if you actually were to climb this mountain, it would be 420 meters. but in the picture you drew, it was 7 meters actually tall, and we'll call this mountain Z. And then mountain Q here. Let's say that that mountain Q is, let's say it's 333.3 meters. It's very specific height here. 333.3 meters tall. And you're trying to draw mountain Q. You've already drawn mountain Z. You have it at 7 centimeters tall. And now you try to draw mountain Q. The question is, how tall should you make mountain Q in your diagram? So you're trying to make your picture look similar, at least, to the actual reality of what's going on. And you could estimate, I guess, and then say that 7 centimeters is 420. So mountain Q is smaller than that, so I would think it has to be less than 7. Like this again. Same problem. When you guys say something, that might reset my mic. I'm not sure if that's the problem.
Hi.
Did that help?
Yeah, it's back to normal now.
Okay. So maybe if that happens, you guys just jump in and say or something weird, okay? And then I'll know what's going on. Does that make sense? Thank you. Okay. And this is our last question anyway, so we're almost done. So please feel free to jump in, okay? Okay, so I'm gonna turn my video off here. I'll just finish this off. So the question is, how tall would mountain Q be in your diagram? How tall would you make it? So you're gonna have to create some kind of scale factor. And what you're gonna have to do is take 333.3 meters, and you need to convert it so that you can figure out in centimeters how tall your mountain should be here. So some guiding things to help you with this is think about what units you'd want to get rid of and what units you're trying to go towards. And what you'll see is scale factors are no different than conversion factors from last week. They're actually exactly the same thing. So how would you put that information in there to get your result? Well, you could do a couple things. You could take the 420 meters and divide by 7 centimeters. And that's one way to do that. It's not going to work out nicely because those numbers do not divide in evenly to each other. It's going to be a remainder left over. So 420 divided by 7. Oh, I've lied. Sorry, they do divide nice. Oh, silly dad. Silly me. Got my kids running around. Got 60 meters per centimeter. Okay. So so that would mean for every centimeter on your diagram, that equals 60 meters in the real world. But the way I've done that, notice that I've got the units meters on top and centimeters in the bottom. And if I stick that in there, I'm gonna get meters times meters over centimeters, which is meters squared over centimeters, which I don't know what that is telling me, but it's not telling me what I want. So that would be a problem. And I know from unit conversions, the whole idea of doing them is to get rid of units. So I want to put meters in here and centimeters up there. So I could say that for every 7 centimeters, that is equivalent to 420 meters. And so if I do that, that would cancel my meters and it would leave me with centimeters. So I'm going to take 333.3 times it by 7 and divide it by 420. And so I get 5.555. Why don't we say 5.6? Approximately. Close to. So about 5.6 meters. And of course, you could do the conversion factor the other way. You could have said 7 centimeters per 420 meters. And that would give me 1 over 60. And so you can kind of see that here is that for every 1 centimeter, that's the same as 60 meters, or 60 meters is the same as 1 centimeter in terms of the map scale. So that's really all scale factor is, and the questions I give you today are not, there's not even very many of them, but if you notice, it really is the same as unit conversion. So I'm going to stop here. Let me stop my recording.